Hello dear students, welcome to YourPedia. Today I am going to solve a question from our NPTEL booklet from the subject Power Systems, that is question number 49. See what is there in the question number 49. Question is very easy. Then why I am solving? From this question we are going to discuss one topic. Okay, one derivation we are going to do. And what does it mean by steady state maximum limit is one of the very important thing with respect to exams and interviews. That word also we are going to understand, steady state maximum limit. Okay, let's read the question first, then derive, then we are going to see. Yeah, read it. If a 500 MVA, 132.2 kV, 13.2 kV, 3-phase generator at 50 Hz feeds through a transfer impedance of 0.0 plus j 0.550 ohms per phase to an infinite bus. Underline. See, infinite bus means grid. To an infinite bus. Infinite bus means what? Grid. How to represent an infinite bus? That also we are going to see. And the bus is also at 13.2 kV. Then the maximum steady state power transfer in per unit on the base of 500 MVA, 13.2 kV is. So what he is saying is, yes, there is a generator, synchronous generator. In fact, there is a synchronous generator. Yes, steam input is given to this one. Yes, this is symbol for steam input. And the voltage here is 13.2 kV. And the voltage angle, let's take it as delta. 13.2 kV at an angle delta. And there is an infinite bus. Infinite bus is represented this way. And there is one transmission line or one connector whose impedance he is mentioning as in per unit 0.0. No, that is not in per unit. So this is kV. And this voltage is also 13.2 kV or 13.2 at an angle 0 degrees kV. So how do you know that the angle is 0? Always infinite bus we will take it as reference. Always infinite bus or grid is taken as reference. Okay, 0.0 plus j 0.550. J 0.550. So this is the system. This is the system. Okay. Now he is asking find the maximum steady state power transfer. Means from sending end to receiving end or to the infinite bus. At the receiving end side there is an infinite bus. How much maximum power, real power we can transfer? How much maximum real power we can transfer? So for this, let's do a derivation. Let's do a derivation in general method. Let's do a derivation in general method. Yes, what is that? Let's see. What is that general method derivation? Yes, I have a synchronous generator and the angle here is mod Vs at an angle of delta. I am connecting to a load where voltage is mentioned as mod Vr at an angle of 0 degrees. This is taken as a reference. Here one point we have to understand. Suppose if I am taking this angle as delta 2 and this angle as delta 1, this is delta 1, this is delta 2 now. This is bus 1, this is bus 2 I call. Then I can write like this. This is delta 1 minus delta 2 and I can make this one as 0 degrees. No problem. Okay. For example, this is bus 1. This is bus 1. The voltage here is 1 at an angle 30. And the voltage here mentioned as 1 at an angle 20 degrees. Now this can be written as, this is exactly same as like this. That is this is a static load. This is 1 at an angle of 10 degrees and this is 1 at an angle of 0 degrees. Means this is delta 1, this is delta 2. This delta we can shift here with minus sign. Then see the difference between these two buses is 10 degrees. That's what we want to convey. Here the difference between these two buses is how much? 10 degrees. So this way we can do. Yes, observe here carefully. All of you observe. Yes. Now let me clear this one also. Yes. And yeah, this is delta 1. This is a mod Vr, not delta 1 mod. This is delta directly. This is at an angle of 0 degrees. and the impedance of this transmission line I am taking it as JXZ is equal to JX. Resistance and conductance and shunt capacitance of the transmission line are neglected. Now let's find the formula for PS and PR. PS and PR. Yes, as there are no shunt elements, the receiving end current is IR, then sending end current is IS. IS is equal to IR, we can write, because there are no shunt elements. If there is a shunt element or tapping somewhere, then there is a possibility for the current division, but all shunt elements are neglected here. Then sending end current and receiving end current both are exactly equal. Now, and one more thing I can say, see, there is no resistance or conductance to have power loss in between. So for how much sending and real power we are giving, the same power that has to be received at the receiving end. There is no power loss in the transmission. There is no power loss in the transmission. Let me calculate PR, receiving end power. PR is equal to VR into IR conjugate. VR into IR conjugate. You know the reason why we are taking conjugate, for the matching of passive power sign convention. For see, what is power factor angle? What is power factor angle? It is the angle between voltage and current. If you are not taking that conjugate, that angle is going to get added instead of a between angle. See, I'll tell you. See, V is 10 at an angle 30 degrees. I is 5 at an angle, I can say 15 degrees. Now, what is the power? P is equal to VI cos phi, where phi is the angle between voltage and current. Now, if I directly multiply these two without conjugate, if I write S is equal to directly VI, then what is going to happen? 50 at an angle 45 we are going to get. Then what is P? P is equal to what, ma? VI cos phi. Cos 45 you are going to get, which is wrong. How much I should get? I must get the angle between voltage and current. See, if I take this one as 0 degrees reference, 30 will be this one. This is 30 degrees, and 15 will be, this is current. This angle is 15 degrees. Then what is this angle? This angle is 15 degrees. Yes or not? So the angle between voltage and current we have to find. The angle between voltage and current. Okay? Yes. So that's why definitely we have to take conjugate. Otherwise, we are going to get wrong answer. Yes, power factor, especially cos phi, sin phi, both are going to mismatch with the actual results. So we IR conjugate. Now what is IR? IR is equal to, see, this current IS is equal to IR is equal to IS is equal to IR is equal to, how we can write? Mod Vs at an angle delta minus mod VR at an angle 0 by Jx means what? X at an angle of 90 degrees. Then what is IR conjugate? What is IR conjugate? Means mod Vs by X. If I put conjugate, delta will become minus delta, 90 will become minus 90. I am taking this minus 90 upside, plus 90 it will become 90 minus delta minus mod VR by X. Minus 90 downside, when it comes to upside, it will be plus 90. This is IR conjugate. Now, PR we have to find VR into IR conjugate. PR, let me write here, PR is equal to VR is mod VR at an angle of 0 degrees into what is IR? IR is mod Vs by X at an angle of mod Vs by X at an angle of 90 minus delta minus mod VR by X at an angle of mod VR by X at an angle of 90 degrees. Yes. Now let's write PR. PR is equal to mod Vs mod VR by X at an angle of 90 minus delta minus mod VR square by X at an angle of 90 degrees. Now, not this is PR, ma. Sorry, I wrote wrong here. This is SR, not PR. SR, yeah, this is complex power, right? In terms of MVA, we are taking V into I conjugate. V into I conjugate will give complex power, not active power. I am finding receiving end complex power. Here also I have to change. This is SR. In overlook I wrote it as PR. SR. Now I want PR, active power or real power. Go with this triangle, power triangle. What is this power triangle? Yes. So this is phi r, receiving end power factor angle. This will be PR, this will be QR, and this will be SR. So what is PR? PR is equal to SR cos phi R, means to SR apply the cos, we are going to get PR. PR is equal to apply cos, mod VS mod VR by X into cos 90 minus delta. Cos 90 minus delta will be sin delta. Mod VR square by X cos 90 will be 0. So what we are going to get? Mod VS mod VR by X into sine of delta megawatts. Observe this one. In fact, PS also we have to get the same. Sir, without deriving, how you are able to tell? Yes, this is very simple, this is very simple. If you look at here, if we are giving a power of PS from here, if we are sending power of PS from here, the same has to be received here. Why? There is no element or equipment which can cause real power loss in the transmission line in this example. Who will cause power loss? Resistance, right? Conductance. There is no resistance and conductance. Yes. Therefore, directly I can write. You can do. See, if you want, you can do. I am writing here directly, that is equal to PS sending end power. So I am giving a note here how to find PS. First, for that you have to find SS. What is SS? Same, VS into IS conjugate. What is VS, mod VS at an angle delta. What is IS? IS is equal to IR, we already have IR. Okay, put here, get the triangle. From that, apply cos, you are going to get a PS also, same as this you are going to get. See, from these I'll tell you a few points. SR is equal to some equation we got, mod VS mod VR by X at an angle of 90 minus delta minus mod VR square by X at an angle of 90 MVA. So if you apply cos, you are going to get a PR. We got PR as mod VS mod VR by X into sin delta megawatt. If you apply sine, you are going to get a Q. Let's find QR. QR is equal to mod VS mod VR by X into sin 90 minus delta cos delta. Sin 90 will be 1 mod VR square by X. If I take mod VR by X outside, this is mod VS cos delta minus mod VR, this is MVARS VARS. Yes. So receiving end real power, reactive power we have. In the same way, if you solve this, apply cos, you are going to get PS, apply sin, you are going to get QS. You are going to have receiving sending end real power and reactive power. Anyhow, sending end real power and receiving real power both are exactly equal. See, in this example, total 4 formulae which are very important for entire power systems we are covering. Okay. Now let's see what he asked. He asked about a maximum power transfer. What is PR? Mod VS mod VR by X into sin delta megawatts. He is asking how much is the maximum power transfer or steady state maximum power limit, maximum power transfer, steady state, maximum steady state power transfer in per unit is asking. Let's find that. So if any quantity is either minimum or maximum, its derivative with respect to variable is equal to 0, then we are going to get the condition for which that quantity is maximum. If I substitute that condition in the equation, I am going to get the maximum quantity. Yes. Now see, in this mod VS mod VR X are constants, then only variable is delta, load angle delta. Now dPR by d delta is equal to 0 at PR equal to PR max, means if you want receiving and real power to be maximum, then the derivative of that receiving and real power with respect to the variable, that is load angle delta, must be equal to 0. Then what is that? dPR by d delta is equal to mod VS, yes, mod VR by X into sin delta, derivative is cos delta, that is equal to 0. That implies delta is equal to pi by 2 radians or 90 degrees. Substitute that one. Yes, PR max is equal to Yeah, what is PR max? PR max is nothing but PR when delta is equal to 90 degrees. That is what? Mod Vs mod Vr by x into sine delta. Delta is sine 90. Sine 90 is what, ma? 1 mod Vs mod Vr by x. Now that is the maximum. See, what is PR max? The maximum receiving end real power is mod Vs mod Vr by x megawatts. Now substitute the given data. That's all. We got the answer. Yes, what he given in the data. So PR max is equal to, yes, mod Vs is 13.2 into 10 cube kV into 13.2 into 10 cube by 0.550. So let me do it. This simple calculation will give us the answer. How much it is? Let's find. 13.2 into 13.2 divided by 0.550. This is 316.8. 316.8 into 10 to the power of 6. But there is one small thing here, that is he want in per unit. So PR max in megawatts is equal to 316.8 into 10 to the power of 6, or already we mentioned it in terms of megawatt. You have to put yes. Now what is S base? For finding per unit value, yes, S base in MVA he given it as 500. For finding per unit value, we need to divide the quantity with the base quantity. Then what is PR max in per unit is equal to 316.8 by 500. Yes, let's calculate. 316.8 divided by 500. 0.6336 per unit. Yes, look at the options, ma. Which option is correct? Look at the options. Which option is correct? Yes, option D suits very well for the given question. So this is a beautiful question, ma. See, question is simple. If you know the formula directly, we can apply. But how many formulas we can learn from this concept? Okay, in what way we learn? See, in examination, yes, it is almost happens that we forget the formula. Then how to derive the formula on our own? Learn the concepts, then definitely you will be in a position to derive your own formula. If you forget, first make sure that you are going to remember the formula in a correct way. But suppose if you forget, yes, it is human tendency to forget, then in this way you can derive total 4 formulas, that is PS, QS, PR, QR, and the PS max also you can find. PR max we already found. Okay, what is the sending end reactive power during PS max? What is the receiving end reactive power during PR max? These many conditions will come. Such a beautiful concept it is. This concept comes under power transfer equations of transmission lines. Ma. Thank you.